Welcome! In these two videos, we will show you how to use the script PhylogenomicSupport.run. This script implements three main approaches to measure support: resampling of individual characters, resampling of genes, and relative Bremer support. In the description of these videos, you will find the links to access to the articles that contain the theoretical basis of the support approaches implemented in the script PhylogenomicSupport.run. As always, I strongly recommend you to read the article describing the approaches included in the script before using them. In this first video, I will explain you how to run the script from the GUI version, while in the second video I will explain how to use the script from the console. For these videos, we will use the same data set from this paper that we use in the tutorial of the script search gene trees.run. This dataset has 251 defined blocks, completing a total of more than 100,000 characters for 22 taxa. Before going to the GUI, I want to point out that this script requires as input not only an alignment, but also a reference tree in TNT format or in NeWID format, because the script evaluates the support for the groups in this reference tree. You may have obtained this tree using, for instance, the script PhylogenomicSearch.run that we have already described in a previous video. Now, in the GUI, we go to the menu File, Open Input File, and choose the script file. Then, a dialog box is opened to choose the data file, the alignment. Subsequently, another dialog box is opened to choose the reference tree. Once we have chosen the data file and the reference tree, another dialog box is opened to define the settings of the support analysis. The first option available is this one that states reference tree is in the NeWID format. It means that if our reference tree is in NeWID format, we must check this option. Otherwise, for example, if the reference tree is in TNT format, as is the case in this example, this option must remain unchecked. Then, the user could specify the gap treatment. There are two options for this: treat them as missing data, or treat them as a new or additional character state. In this example, I will treat the gaps as missing. Now, here we have the search settings for each one of the replicates of the resampling analysis. For this step, the user can choose between two major options. The first option is to speed up the analysis using an approach called FAR. It means fast approximation of resampling. Please read the details of this approach in the article. This approach takes one of the optimal trees for the whole dataset and eliminates the groups, using TBR collapsing, that become unsupported for a given replicate of character resampling. And the second option is to perform a full search in each replicate. The settings for this second option are identical to those of the script PhylogenomicSearch.run, so we recommend watching the tutorial of that script. For this example, I will use the FAR approach. In addition, the settings related with character weighting are the same of those of the script PhylogenomicSearch.run. For this example, I will use equal weights. Now, These are the most important settings of this script, because it is here where we define the different support measures to be calculated. First, it is possible to choose among 4 different approaches to resampling individual sites. These 4 approaches are bootstrapping, jackknifing, symmetric resampling, and an approximation of the resampling frequencies using combined Bremer support, also called CVS. As in phylogenomics it is very common to have inflated support values, we included here some approximations that spread or disperse the support values to better rank the nodes. In this script, this could be achieved by increasing the deletion or change probability of the sites for the jackknifing and the symmetric resampling approaches. While for the CVS approach, you can check the option disperse values. In addition, you can also perform a jackknifing analysis by resampling entire genes or loci instead of individual characters or sites. Here it is also possible to change the deletion probability of the genes. The number of replicates that is here applies for both the resampling of individual sites and the resampling of genes. Finally, you can also calculate the relative Bremer support. For this example, I will perform a jackknifing by sites using a deletion probability of 90. In addition, I will perform a jackknifing by genes using also a deletion probability of 90. I will use 100 replicates, and I will also calculate the relative Bremer support. The remaining settings are related with the output files produced by the script. Here I will generate a SVG graphic. The name of the output file with the support values in parenthetical notation will be support 1.3, and this output file will be in NEWIC format. Finally, I just need to press OK. This script takes approximately 45 seconds with these settings for this dataset. However, I have also already the results here. Here is the SVG graphic. The first values correspond to the jackknifing by sites. The second values correspond to the jackknifing by genes. And the third values are from the CVS approach. In addition, you can also see the results using Fig tree. Here you can see the tree with the support values in the same order that I showed you in the SVG graphic. This is the end of the first part. Thank you, and see you in the continuation of this tutorial, where we will show how to use this script in the console version of TNT.